Alright, so first thing we'd like to do to solve the fsm.sim file is to fill out this truth table. Alright, so in order to fill it out, you just look at the diagram, and these two bits are basically the current state number, and this G bit represents the transition. So if we're in state 0, 0, which is this state, and we take the 0 transition, which is, I guess, G naught, which state do we go to? Well, if we just follow the arrow, it looks like we go to state 0, 1. That's going to be our next bit. And these three are basically represent the functionality within the state. So looks like if we're in state 0, 0, the only thing that's turned on is background music and everything else is off. Yep, and I guess we can do another state. Let's try this next one. If we're in state 0, 0, and we take the first arrow, which is this G arrow, G is 1, looks like we go into state 0, 1 again. And within the state, so ignoring the transition, ignoring the next transition, what I like to call control signals are turned on. Well, it looks like just background music and the other ones are off. So I would follow the same pattern with the rest of the states. Alright, so once you fill out these rows, 0, 1, 0, 0. Alright, now for each column in these outputs, they'll have their own K-map. So in order to fill out the K-maps for this, well, it looks like the first one's BGM. So let's see if S1 naught, S0 naught, and G naught, that corresponds to this row. So in this row, I look for the BGM column and I see what it is. It looks like it's 1. Here, I'll put a 1. Now, S1 naught, S0, G naught, that looks like 0, 1, 0. Looks like I haven't done it yet, so that's your guys' job, but whatever you come up with here, you can copy this answer over and paste it into this little cell. Looks like we did do this one though. So S1 naught, S0 naught, G. It's going to be 0, 0, 1. I look for BGM, type in 1, I put G there. Same thing, you got to do it for every column. There's an individual K-map. And then you got to use your tricks we learned in lecture and lab to write the groupings. Remember, try to make the groupings as big as possible and try to keep as less groupings as possible. And overlap is encouraged. Overlapping is very, very, very encouraged. It helps make your terms more simplified. Alright, so once you're done with the K-maps, I would keep your K-maps side by side. And now you might notice there's 3 outputs, but you have 5 K-maps. So where are the other 2 K-maps for? Well, actually, that's because 2 of the outputs are actually related to state. The next state bits, right? So, in order to, this is what I would do. I'd put a splitter right on this input state. And I'd read this out. So this looks like this one bit is our N0 bit, so I'd make a tunnel. N0, if I read this, that's 1. I'll call that N1. Alright, great. So now I can just keep a tunnel here. N0, N1, and then those are all our 5 outputs, and you should have a K-map for each one of these. So let's just say your K-map for EG music. So you come up with this is an example. It's probably not the answer, but like say it's S0 naught G plus S1 or something like that. Well, how can I implement a circuit for that? Well, I can actually just read it out loud and then implement the circuit. So how can I read this? This is S0 naught and G. So there's going to be an AND gate there. So how can I access S0 and S1. Well, that's actually just the current state. So with the access that, I'll make another splitter here. I can access the individual bits. Make space. Or something. I'm not sure how to do this. Come on, one of these gotta work. Okay, there. This one's nice. Looks like this one is S0 bit. This one is our S1 bit. So, in order to, we need S0 not. So negate one of these. I'll put our S0 in there. Looks like we also need AND G. And G is already has a tunnel, so I'll just put G. And looks like it's OR S1. So I'm not going to connect this right away. There's going to be an OR gate in the middle. And I would put S1 as the other input of that OR. And then I can just connect this to our output. So you can see I was just reading the K-map solution I wrote. In a logical order, I was able to implement circuit be S not and G, or S1 is background music. And you have 5 K-maps. You have to follow a similar process for all 5 of these pins. And then you should have a functioning finite state machine. You can start playing around with it and see that the transition should be following a diagram, as you said, and the outputs BG music, sus music, and sabotage are going to be lighting up as depending on the state you're in.